It finally seems that YouTube is working and you probably can see me. It finally seems that YouTube is working and you probably can see me. Please let me know. It finally seems that YouTube is working and good. Let me know if you can hear me and you can see me. Yep. Good. Let's start. I'm Andrew Tropin and today we are going to talk a little bit about Nix and Guix. Despite the name of the stream, I wouldn't advise to use any of them, but I will try to compare them and will say what the reasons behind my decision and will get you some knowledge, I hope. First of all, let's start a little from history. And first, Elko Dolstra created a NixOS and Nix package manager, started to develop the research project in 2003, and it's already almost 17 years. And now it's a pretty big project which grown from small research to really big Linux distribution and really good package manager. And in 2008 he wrote an article, probably his PhD thesis was about functional package managers, and I hope most of you already know what those functional package managers do and how they works, at least on high level. But for people who don't know, I will make a very brief introduction. Functional package managers do a very interesting trick. They use a separate folder in your file system. For example, for Nix it will be Nix store, and for Guix it will be GNU store, which contains all the packages available, all the packages which was built or was downloaded to the system. And as you can see, all those packages has a hash prefix, name of the package and version of the package. And this hash is generated using the definition of the package, which guarantees that if you change something in package definition, for example compiler, which you use to build this package or some dependencies, the hash will be different, and that means that this package will go to a different directory. And it also means that if you build two similar packages, they will go to the and they go to the same directory. That means that they bit identical. It's not 100% true because of bit flipping and other problems that can happen. But in most cases, if you build the package, it would be a bit identical if it has the same definition and same inputs. And after that, you can build profiles. Profiles is basically a directory which has symlinks to the packages, and you can use those profiles, for example, setting path variable pointing to bin directory of that profile, and this bin directory will contain all symlinks to all the packages that you declared for this profile. And the same work for operating system. You can build a profile for operating system which contains all the necessary files, all binaries, all documentation and other stuff, all the libraries, kernels and so on. And after that you just link to this profile from your root file system. For example, if we go to the root of my PC, you will see that it looks like a basic Linux distribution, but if we take a closer look to bin directory, we will see that it's pretty skinny and contains only sh, and sh is actually not a real file but a symlink to sh file inside bash package, which is inside Nix store. That means that the whole operating system, the whole file system hierarchy is just a combination of different packages from Nix store. And nice property that we gain with such get with such approach is that you can have only Nix store and boot available in your system, and during the boot all the necessary symlinks will appear. And also another nice property that you can load to previous generation of operating system, and if it specified in your grub bootloader, you can just pick it, and all the necessary symlinks will be set up according to this generation of operating system. And if you failed or broke your operating system, you can roll back to this version, to previous version of operating system, and start fixing something. And the same works for profiles. You can easily roll back your profile to previous generation. On each operation on profile, next generation appears, and you can jump back and forth between those generations. And that's basically it about functional package managers. And let's go closer to the topic about Nix and Guix differences. And first very important difference that you will mention at the beginning of using those operating system, that Nix has pretty easy access to proprietary software. There is a lot of packages inside Nix packages which are not free in terms of free software, and it's easily accessible. You just need to set a flag to get them installed. Without this flag, you won't be able to install them. For example, you can't install Steam or CUDA or something like that without setting this flag, but it's relatively easy to get them. And from one point of view, it's a plus that you can easily install such software. From another point of view, it's not very good because you use proprietary software and you don't know what inside, and that means it's some threat for your privacy, and you don't know how the software works and how it executed and what it does. And you lose your freedom. And opposite side of the relation with proprietary software is Guix. It's completely free. The main repository doesn't contain any proprietary software. All the software is free. Okay, I see comments from Roptot. I will mention it, sure. And that means that you can't install Steam and CUDA from official repository of Guix, and you even won't be able to install a Linux from official repository, because it contains libera.Linux, which is basically Linux but without binary firmwares. And it can be hard to do your first installation because many modern hardware doesn't work without proprietary firmwares. There are few solutions. First of all, you can buy hardware that supported by your software, and actually it's a good practice, but in case you don't follow this practice, it's also possible to find already packaged software for Guix, which is proprietary. It's not the best way to solve this problem, but sometimes it may be a solution. Thank you, W96K. Roctat already mentioned that in addition to Linux, Guix supports a hard kernel. It supports experimental, and I actually even written here that hard is supported, but for some reason I removed it because it's in early stages of support and you can run it only on virtual machine. And it's nice to develop and participate in this project, but it's not usable for end user. That's probably why I didn't mention it in the table, but okay, it's a cool comment. I will place it in this table. And also Nix as a package manager also supports Mac operating system, which probably won't be supported by Guix in any future, or maybe never, probably never. And it has a pretty good support until Apple broke something with file systems, and it's necessary to update something to make Nix currently work on latest macOS version, but probably it's already fixed. But maybe in some future even Nix will drop the support of Mac. I don't know how it will go, but I don't see it as a problem that Guix, for example, doesn't support Mac. But both package managers can be installed on different GNU Linux operating systems, and maybe even on other operating systems like BSD. I'm not sure, I didn't try, but probably it's possible. And let's go to next important point. It's packages, repositories for those packages, and the number of the packages. From Repology, I found out that it's a lot of Nix packages. Actually, only our Arch user repository contains more packages than Nix currently. That means that Nix probably the largest repository currently, largest software repository of Linux. Why largest? Because our is not official repository, and Nix packages is official repository of NixOS. That means that officially Nix contains more packages than Arch. And even if you talk about Arch user repository, Nix also has Nix user repository, which contains also a lot of packages and more additional channels of packages like Emacs overlay and many others. Guix contains much less packages currently, but probably it contains almost all popular packages that you can find, and many packages will appear, but it probably will be less than Nix packages, at least because Nix packages contain some proprietary software. And also you can see that Guix is much younger project than Nix, and it's also the reason why the number of packages is much less. Another interesting story about those repositories of Nix packages and Guix is that Guix repository contains not only package definitions but also tools for managing your operating system. Also the same works for Nix packages, but also Guix contains the source code for Guix command line utilities, and Nix packages has a separate repository for Nix, and Nix package declarations written in Nix language and Nix utility written in C++, while Guix utility CLI is written in Guile scheme, which is the same language used for package definitions. And we slightly switching our topic from packages to languages, in which those packages are defined. And for Nix Package Manager, the author of the project decided to create his own language called Nix. It's pretty simple and probably clean functional language, which supports all basic data types like attribute sets, which are similar to dictionaries in Python, or hash maps or maps in different languages. Also supports lists, strings, and so on. And actually I have a talk about Nix syntax, and you can find it on my channel. But the interesting thing about this language that it's DSL and it's not general purpose language, and that's mean and it's pretty young language comparing to GNU-GAL, for example. It contains less functions. It has less libraries because it's used only in Nix and NixOS, and it has smaller set of tools comparing to GNU-GAL. And GNU-GAL is more mature, full-fledged scheme language. It's a dialect of Lisp. It's pretty widespread, has a lot of libraries, and also has a great tooling, at least for Emacs, but also for other editors, I think. That means it's a little easier to develop in GNU-GAL because it supports go-to definition, inline documentation, and so on. But talking about Nix, I would say that it's pretty easy language to understand, and I will show you example of Nix language. In most cases, you will see something like that, writing your configuration. And it's pretty clear how it works. You can define a key or a path of keys and the value for that key. And it will be definition of some property of some nested key. And it looks both as language and as a configuration file format. That means that people who don't write anything in this language, they will use it as a configuration tool, and people who program something or develop something will use it as a language with support for defining functions and passing parameters, doing some recursion, traversing of nested data structures, and so on. Yeah, it's a nice property for newcomers that it's pretty easy language to start, but a little harder language to develop in. Yep, I think it's most important points about comparing those languages. And let's go to the next topic, is documentation. As you know, Guix is a GNU project and GNU operating system, and probably because of that it has a pretty good support of other GNU projects. It has GNU Shepherd as service manager. It uses GNU Tech-Info for documentation and GNU-GAL for implementation, and so on. And because of that, all the documentation somehow related to each other. And for example, if I open GNU info utility, actually the implementation of this utility inside Emacs, which is actually the same as CLI utility, but it doesn't really matter. Inside this utility I can find Guix. Actually I can scroll to it to make it more clear. It's a lot of topics for GCC here, and you can find somewhere here. Okay, I can just use search. Yep, like right here, you can see that it has a link to Guix manual, to Guix cookbook, and some other Guix topics. And let's go to Guix manual. Inside this manual, we can use index to find a topic related to searching packages, for example. Search for packages. And this search will lead us this index will lead us to parameter to Guix package subcommand, and it has a reference to GNU recutils, and recutils is another GNU project for relational databases, and I can click this link and go to this manual for GNU recutils. And also I can scroll somewhere and see another link to GCC, and you can see that it already works as a link, and you can go to GCC manual, and it's a pretty tight integration between all those GNU tools that I very like. And it's not only example which you can find, not only documentation is tightly coupled, but a lot of other things also pretty tight integrated. And that's not so true for Nix, because Nix is a separate project from GNU, and it's also a research project. It's more like different parts glued together somehow, and not so well integrated. It's my own opinion, maybe it's not true, but it's how I feel right now after a few months of usage of Nix and NixOS. And another thing that a little annoying about Nix is kind of inconsistency. For example, currently I have Nix version 3.0, but if I will use Nix from stable channel, I will get Nix version 2.3.6, and there was another version of Nix CLI utilities, which was the first one, and it was actually a collection of Nix build and Nix prefixed utilities, which you can combine somehow, nixenv and so on, which had a slightly different interface in terms of flags they accept, and it was a little hard to learn them all and to keep in mind all those parameters. In contrast to it, Guix has only one utility, which contains a lot of subcommands. And currently Nix also has something similar. It uses only one Nix utility, and it contains a lot of subcommands to work with your Nix expressions. The problem is that it was a good switch, but there are a lot of tutorials and so on which use a first version of Nix utilities, and more importantly, currently third version of those utilities is in process of development, and it's not it will break backward compatibility with the second version. For example, currently I can do Nix search Emacs with second version of Nix tools, and it will show me all the packages matched to the search. And with third version of Nix utilities, if I type Nix search Emacs, it will throw an error to me, and I need to specify Flake registry that I want to search package in, and only after that I will be able to search those packages. That means that it's some evolution of this Nix tooling, and we need to understand that Nix is much older project and contains much more legacy, and they have to switch to new version of tooling somehow to make it more consistent and pretty. But it's actually an advantage for Guix because it started later. It could look at problems of Nix, and it was created with some problems in mind, and it was implemented a little better with more upfront design. And as a result, it's more production grade distribution, in my opinion, than Nix, because Nix is more like a research project. But we already know that Nix is much older. It contains a lot of tools in his ecosystem, and it also used in many different organizations, contains more packages and so on. That means that it will be some race between Nix and Guix in the future, I think. And in terms of CLI, I prefer Guix because it's more modern, consistent, and well designed, while in Nix there already the third version in progress, but it's still not well implemented yet. It has some problems. For example, it doesn't have completion for ZSH and some other problems, and also it will break compatibility with the second version, which is also not so great. That's why I will pick the Guix CLI in this competition. About branching model, yeah, I agree. W96K. Can you tell your name, because it will be easier to tell you by name to answer your comments. Yeah, it's very cool that Nix decided to unify CLI, and it's pretty cool to see how it develops. About branching model of those distributions. Oh, Michael, sure. I saw your repository on SourceHut, and I just forgot your name, sorry. Branching model in Nix, it has 2 releases per year, somewhere around autumn and somewhere around the end of the spring. And that means you can track those branches and use like stable releases, which contains only backports of some security updates and so on. Or you use unstable branch, which contains all the latest software but may contain some broken packages and so on. And Guix is almost rolling release. That means you almost always tracking the latest branch, but it has some text like 1.0, 1.1 and so on. But as far as I know, there is no really branching model, and mostly you use it as a rolling release distribution. Going further to service managers. Nix uses systemd, which is widespread monster which can do almost everything you want. But for our case, we're talking mostly about managing services and initializing of your system. And systemd is kind of overkill, and some people not sure that your init system service manager should be so bloated. But from my point of view, it works okay. I didn't see any problems. It's a little hard to read very long documentation on it. It's not simple. It's not a simple tool, but it do a job and do it pretty good. I can't complain about it. The small problem that I see here, that you have to learn a new syntax for defining your services. And GNU Shepherd is Guile, has a Guile interface for defining your services, and you can define your services in pure Guile, and its GNU Shepherd is also implemented in Guile. That means it's more tightly integrated with your operating system, and it's much simpler. It do less than systemd, but I think it's a good thing that it has a smaller scope and less places for getting into trouble. But it won't be fair to say that Nix doesn't have a Nix syntax for defining services. It's possible to define in Nix syntax those systemd services, but actually you need to look at systemd documentation first to understand which fields you need to define, and after that you can define them in Nix syntax. That also feels kind of hacky gluing of two different tools with some glue. And as Michael says, it would be cool to have a stable branch for Guix. Yep, probably it's a cool thing to have a stable branch, but it will increase maintenance burden. It will make a lot of work for maintainers, and for now I think that it's good that maintainers doesn't have to do a lot of work for maintaining those stable branches, and they spend this time for developing Guix itself, and later maybe someday the stable branch will appear. Yeah, and as Rob.tat say, that stable branch means that you will also keep old Guix CLI utilities. Which also will create similar problems to current Nix, I think. It will be hard to migrate to a new branch and so on. And for now, until everything stabilized, I think that it's very good that Guix has kind of rolling release. Going further, when you define the package, both package managers generate derivations which will be evaluated by build daemons, and in most cases recipes for building actual software is in Nix is written in bash, and it's concatenation of different strings into bash script, which will be executed during the build phase. And Guix using a different approach, it actually a closure of package dependencies and also some Guile code, and this means that build expression for Guix daemon will be a scheme code, which also increase integration between your operating system, your package definitions, and daemon who builds it, and everything is written in scheme. Your services defined in scheme, your packages defined in schemes, and even your build script defined in scheme, and it gives you some power. But for Nix it also works creating bash scripts from strings. It has pretty nice tooling for operating on multi-line strings and concatenating and building some values inside strings. That's mean J expressions is very cool conception. but bash is also works. And let's go to another interesting topic, which actually I discussed with Ludovic today in IRC chat. It's how version of some Nix expression is frozen. For example, when you write Nix expression, you can define a flake file. Actually, it's pretty new technology and not in stable release of Nix or NixOS, but it will appear a few months later, I think. You define only one function which accepts some inputs and provides some outputs. And you can call a special CLI tool which create log files which frees all the inputs for this function. The interesting thing about it is that as inputs, another flake can be used, which can contain other dependencies, and you will get transit dependencies also logged. And because a Nix language doesn't have namespaces, and all the packages defined inside some attribute sets, which is basically dictionaries, you can have two different versions of Nix packages inside one log file, and you can access both versions of those Nix packages. That means that you can have in one profile two different packages depending on two different Nix package versions, which is pretty cool and pretty flexible, I think. In Guix there is a mechanism called channels, and you also can get a list of dependencies, also transient dependencies for your project. But if it contains two channels with the same name, it will use the one which has more precise specification, like which contains commit or exact version of the commit, and it will use this one. Partly because it evaluated in Guile, and if you have two channels with the same name, you will get a name collision inside Guile namespaces. But I hope it's not a big problem. I don't have a lot of experience with such case, but I think it's solvable. At least there are a special mechanism called inferiors, which can use two different versions of Guix inside one Guix build daemon. Actually, Michael already mentioned that we can use inferiors for that. It's a little harder and it requires a little more work, but I think that this case may be very, very rare, and it's logical to use such a hard mechanism as inferiors instead of using those flake-like lock mechanism, which allows to use few versions of the same Nix packages. And in this point, I would say that Nix a little better comparing to Guix. Just my humble opinion. I like Flake's approach a little bit more, at least for now. But maybe later, when I will get more experience with channels and with Guix, I will be thinking different. Okay, I hope I won't miss it, but let's see. Maybe I will need to just implement something like flakes for Guix later. About consistency, I'm not sure that I wrote it correctly. Nix has a little more consistency in terms of CLI and other stuff, and Guix has a higher consistency, and it's more well integrated between components. We almost already finished. I already said that CLI implemented in different languages. It also somehow contributes to consistency. Bootstrapping. Interesting point about bootstrapping. Those functional package managers and operating system based on them cares about reproducibility, but you can't guarantee reproducibility if you can't build a compiler which builds your software. If you use a binary version of your compiler, you don't know where you who and how built this version of compiler, and you need to build the compiler yourself, and to build it you need a simpler compiler which will build this compiler. And going further to the beginning of the world, you need very simple binary file which can be audited by human to be sure that it's not malicious software and it's just a simple compiler, and you will get the chain of compilers building themselves, and this process called bootstrapping. And I don't know about any attempts of bootstrapping for Nix. Maybe they exist, I just don't know about them, but I know that people are aware in Guix community about bootstrapping problem and about trust problem. And actually the project called GNOMES, I think. I'm not sure about the name, but probably something like that, which actually cares about this problem. And Guix has pretty small seed, and this seed is a archive which contains all the binaries necessary for building for bootstrapping the whole distribution, around few dozens of megabytes, and probably it will be decreased to even less size, and it will be clear that this distribution is fully bootstrapped, and that means it will increase reproducibility much more. Yep, I think that's all about bootstrapping. Let's talk about one more important thing and conclude our talk for today. Another important topic is a model system. Nix has pretty good model system, and this model system allows to the user to define the configuration using those attribute sets or dictionaries. The user just defines some values, and model system evaluates this definition to operating system or to something else, in most cases to operating system. And developers define models, they define options which available to user, and user can define those options to get some desired behavior. For example, here I define some value, lib input enable, or I define that my display session will be just starting .x session. I define that I want to enable PyCom compositor, or I want to have a Docker enable. All what you see here is options defined by some developers, and there are some implementation behind those options, which allows the model system to build your operating system with all necessary functionality. And it's pretty good and easy to use, in my opinion, and it's very nice for newcomers, because they just go to the site or go to manual page and just open those options and look for something they would like to use, for example SSH daemon, and they just see that there is option to enable SSH daemon, and you just set it to true, and you have SSH daemon in your system enabled. And similar works for some programs. For example, you want to have Chromium extensions, and here you can see Chromium extension options where you specify the extensions that will be installed in your Chromium browser during the build of your system. And using this model system, you can build your operating system pretty easily, and it has a lot of defaults, which simplifies configuration process of your operating system. I like it in terms of as a user, but I don't like it in terms of developer, because when you work with such hard thing as a model system, you can break your mind trying to understand how it works, because one model can define options for another model, and everything is merged somehow, and during this merge you have some priorities of those options, and it's very hard to track process, and you can find yourself stuck with debugging this the model you're trying to implement, because it's really not so clear how it works, even if you have experience with it and you read a lot of source code, but it's really easy for user. And in contrast, in Guix you don't have such model system. From point of view of user, it's a little harder to configure Guix, because you need to set a lot of configurations files more manually, but it's still not so hard to configure it. It's still manageable task, but you need a little deeper understanding of underlying operating system to do it. That means that Guix uses simpler approach, but it's not so easy as Nix approach. I hope you can feel the difference between easy and simple in this context. And about implicity. In Nix language, I had a lot of events when I tried to understand how this value passed to this scope, and it contains a lot of implicit variables passed from somewhere to this point, and it's hard to track until you get familiar with Nix language. And with Guix and Guile it's less implicit moments. There are some implicit moments still, but much less than in Nix. Yep, and my table is over. If you have any questions, ask them in the chat, please. I will try to conclude my talk. I think that both distributions are great, and thanks to Nix developers that they created such a beautiful distro, and which lead to developing of Guix. And thank you to Guix developers that they developed such a great distro which has a very tight integration between all those GNU components, and provides much more pleasant experience for developers. And I hope much more people will enjoy functional package managers in the future, and will join one of those distributions. Yep. Yeah, I can share my org file. I will place it somewhere and will post a link in the description of this talk. Also, I can send it directly to you, Michael. I think that's all for today. I'm glad you joined and hope you enjoyed it. We'll see you in the next stream. Oh. See you soon.